All right, let's go. So, hi everyone. So today I'm going to talk about dependency injection. So inside our favorite framework, Angular, of course. And as Minko said, DI is one of the most loved and powerful features of Angular. So understanding it deeply can level up your Angular skills. So in this talk, we are going to discuss what is DI in general and why is it so powerful. Then I will show you some common use cases that you might write every day at work. And lastly, we will see why Angular is so powerful and efficient at doing dependency injection. And we will go back to the previous use cases to see how they can be improved. So first, let me introduce myself quickly. I'm Thomas Laforge. I'm a freelancer from France with a strong expertise on Angular. So let's jump. So what lies beneath the term dependency injection? First, let's see a small snippet like this one. In this small snippet of code, we instantiate root service within app component, but this results in a hard-coded dependency and a strong coupling between app component and root service. So this approach is not very flexible, testable, or scalable in the long run, making it less maintainable as well. If we do the same with the DI system, we only need to inject the name of the class or the interface or the token to get the desired service. So since v14 of Angular, you can use the inject function, but that's doing the same thing as the constructor. So you can use both as you like. So when we inject a service, we will delegate the work to an external source. And the work of this source is to search the desired instance of the requested service. So as you can see in this example, app component doesn't need to know anything about how root service is implemented. So this decreases the coupling between the component and the dependency. In Angular, the external source is called an injector, and its implementation looks like a dictionary of value. The injector will store all the information of all injectable classes you can find in Angular, like services, components, pipes, directives. And so in this example, we are requesting root service, for instance. Then we will iterate over all the keys inside the injector to find the requested token. And once found, the function will return the value if it's not undefined, or construct a new instance through the factory function. So as we can see, it is very easy to override the definition behind the key root service. In Angular, you have a provider array within the component decorator where you can override dependencies. Like in this example, we are using the other service definition through the root service key. So inside the injector, we will override the definition. We can also use factory, for instance. This function will target the factory property inside the definition. And in the same way, we can use value to target only the value inside the injector. There is one last property you can use, is use existing. This will only create an alias to get another definition inside another key. So this is why DI is so powerful and flexible. And this answers one of the solid principles, which is the dependency inversion principle. So app component is not responsible for providing the requested service. It only needs to know the API and not the implementation details. So this creates highly decoupled applications, which makes them flexible, testable, and maintainable in the long run. So now let's dive a bit more inside Angular and see how we can construct those injectors. So in Angular, we have two categories of injectors. We have the environment injectors, where you find all the global services, everything that you provided in root, or everything you provided inside the modules, if you're still using module, or inside the router provider array. And on the other side, you have the node injectors. So every view inside Angular, so I said view and not template because it's a slightly different definition between a view in Angular and a template. So every view has one or more injectors. And within those injectors, you can find the component definition. You can find any services provided within the provider array of your component provider array, or any directive you applied on the view. So how Angular constructs those categories? When we ship the code to the browser, for instance, and the browser executes our code, it will first call Bootstrap application function. Within this application, we can give them two parameters. One is the root component of your component tree, and the second is a set of configuration properties, where you can find providers property, where you can set up some global services. So when Angular executes this code, it will first create the null injector. So the null injector is the end of the road. When you reach that point, it means the DI system didn't find any provider for you, the provided services you are requesting. So you will break the application and return a null injector exception. The next injector that Angular is creating is the platform injector. This injector lets Angular knows on which platform we are working with, like for instance, the browser, server, web workers. And it gave you some elements that you are working with, depending on the platform you're working with. For instance, the document of the DOM. And the last one is the root injector, that the injector you're working with the most, because it stores every global services you are using. Well, I gave some example of built-in tokens like Event Manager plugin or Renderer Factory 2. For instance, if you want to see some custom implementation of the Renderer Factory 2, Shotran has a very good presentation on this one. Is using the DI to override the Renderer Factory to suit its needs better. And of course, you can find anything you provided inside the provider array within your Bootstrap application function. So once those environment injectors are created, we will call the Bootstrap component with the root element. So in our case, app component. So here we have like an example of a component tree you can find in your application. It will be a lot more bigger, but for the presentation, this is enough. So we will, after creating the environment injectors, we will create the app component. For instance, we can have this component. So Angular will create a new instance of a node injector. Within this node injector, it will register app component, because the app component can be injected anywhere else inside your children. And we will also register anything you add inside the provider's array, like app service in our case. So as I mentioned before, we will create a new node injector per view. In this example, we have multiple views. Every structural directive creates a new view, like ng4, ngif, or custom structural directive you can have in your application. And each view will have its own node injector instance. So for instance, if in this example we have an array of 4 elements for ng4, we will have 4 node injector created. So just a brief note aside. So if you followed the RFC on signals, when we talked about fine-grained reactivity on views, it's what they meant. It's not, we will not refresh the full template of the component, but we will refresh the view on which the signal was changed. So let's go back to the presentation. So once the node injector is created, we will enter the injection context. At that time, we will try to inject everything that we are requesting. So in our case, global service. We will delegate the work to an external source, so the DI system. This source will iterate over itself first and iterate over each element which is registered inside this injector. If we don't find it, we will move up to the environment injectors, and we will do the same inside the root injector until find it. If we don't find it here, we will move to the platform injector and so on. But here we find it here, so we will return the value if it's not undefined, or we will construct a new instance through the factory function. Next, after everything was injected correctly, we will move to the next element inside our component tree. So in this case, child1 component. So we will create a new instance of a node injector, and we will register child1 component inside this injector. Same thing, we will try to inject app service, we will delegate the work to the DI system, and we will iterate over ourselves first. If we don't find it here, we will move one level up. So since child1 was encapsulated inside ng4 directive, we will first look inside the ng4 node injector. If we don't find it here, we will move to the app component node injector. This time we find it here, and as you can see, the value is undefined. So we will construct a new instance to the factory. But I just want to point out one small warning. When you provide a service, it doesn't mean, but it means it's not instantiated yet. So you need to inject it to instantiate the service. So if you have some logic inside the constructor or inside the use factory, for instance, for a token, it will not get executed until you inject it somewhere in your application. So next, we will move to the next element, which is the same template, but Angular is creating a different node injector. So the view, there will be two views, but one element. So we will do the same. We will request app service. We will first look inside this injector, inside ng4 injector, and then inside app component injector. This time we find it here again, but we can see that the value has been instantiated this time. It's because the both elements are sharing the same instance of app service, because app service is providing within the parent element. In the next case, for instance, we are providing again app service in this component. So as you can see, we provide app service in this one. So it will get registered inside this node injector. So when we will request the service and look inside this node injector first, because Angular will look from bottom to top, it will reach this definition, this key, I mean, and look inside the definition, which is the value undefined again. So we will instantiate it again. We are not using the same instance as the other child1 component because we are stopping at child2 component since we provided it here again. So now let's go to child3 component. But before going to this one, we need to go back to child2 component and look within the template. So as you can see, child3 component is encapsulated between two divs, inside the div, I mean. And inside this div, we have a directive on it. So Angular will create a new node injector instance for the div. Alors, the difference between this one and the ng4, it's not creating a different view. The view of both node injector will be the same, but there will be two different instances. And then for the self one, it will register the self directive on the child3 component node injector. So now let's move to child3 component. We will register child3 component inside this node injector. And now we will see how we can fine-tune the GI system. There is 4 flags we can use to be more precise on what we are looking and where we are looking for the requested service. So in this, the first example, we are looking for T, but with the flag host. It means that we will iterate over our component, go on the host injector inside child2 view, but we will not go any further. So if we don't find the dependency inside those two node injectors, we will break the application with the exception. The self flag, it's a bit more restrictive than the host flag. It means we will only look inside ourselves and not go any further. The skip self flag, it's the opposite of self. So we will we will skip the first iteration and jump straight to the second one and move up and up until finding the right dependency. And the last one, the optional flag. It means that if we don't find the requested dependency until reaching null injector, we will not break the application, but return undefined instead. So those flags can be grouped together. You can use them. You can use optional host and skip self, for instance, all together. So next, I just want, so Angular will create the other element, and we will move to one last example, the type 6 component, for instance. So this element, we are requesting the route service. A route service is a service providing in route. So what does it mean? It will do the same, going up and up and up until reaching the environment injectors and the route injector. But this time, even if we don't find the route service inside this injector, we will not go to platform injector yet. We have one more step before. We will try to match the scope of route injector with the scope of route service. Since in this case, both scopes are the same, route, we will add route service within this injector and return a new instance. So this is why injectable services with the provideIn property are tree-shakeable. So this means that if you provide this service within or inside the lazy loaded modules, the code of the service will be bundled with the lazy loaded modules and not inside the main bundle. So you can split your code more precisely using provideIn property. But iterating over each injector to check if there is a match is not very efficient and can be very costly when your application grows. So Angular is a bit smarter than this and use the Bloom filter to overcome this issue. So what is the Bloom filter? So the Bloom filter is a probabilistic data structure that tests if an element is present. If you test if an element is present inside this Bloom filter, it will answer no with 100% accuracy, but you will get a maybe if the element is maybe inside the Bloom filter. Moreover, this is a very cheap operation because we are working on bytes. So how can we apply it to the DI system? If we look at the app component again, Angular will add a new instance will add a unique instance of a Bloom filter inside each node injectors instance. So when we will register app component, for instance, Angular will add a unique ID. So on the class, we'll hash it to fit within the Bloom filter. So the Bloom filter is 255 bytes, and we will swap the first byte to 1 bit to 1. We will do the same for app service. We'll add a new unique ID, hash it, and swap the second byte to 1. Then when we will try to inject app service, for instance, we will look inside the app service class, find his ID, and hash it back to find his corresponding bit. In this case, we get a maybe answer because the bit is 1. So we are not sure that the app service is here. Why maybe? Because, for instance, if we are requesting random service with an ID 256, we will get the same hash. And that time, Angular will enter the node injector and iterate over each element to be sure that app service is here or not. But in the opposite scenarios, if we are looking for other service with an ID 3, we will get a bit of 0. We are 100% sure that the service is not present inside this node injector, and Angular can go to the next element safely. One last trick that Angular is using is when we are requesting services providing in route. Those services have an ID of doesn't have any ID because we didn't register them inside any node injectors. So when the ID is null, we can straight jump to the environment injector because it means that this service wasn't registered inside any node injectors. So this speeds up the process a lot because you don't have to go one node injector by one node injector until reaching environment injectors. So thank you for listening to my presentation. I hope now you have a better understanding of how DI works under the hood and how it injects your services, and most importantly, what instance of your service you are getting. So if you have any question and want to reach out to me, here's my Twitter account or my LinkedIn account. So feel free to ask me anything, or you can give feedback also. I will highly appreciate it. So thanks again and enjoy the rest of the talk with Adi and Marcus.